Nerd.
So guys, welcome to a new chapter that is motion in two dimension, and the first topic is projectile motion. And we start with what is 2D motion. We've already talked about this, that when position, we've already talked about this in 1D of particle determined by two axes. Suppose this is the y-axis and x-axis, and a particle's position is like this. So the position is between x and y-axis, or this can be like y and z. This is between y and z axis. So two axes are required to find out the position. This is basically 2D. We can represent it mathematically as suppose this is position. Position is xi cap. Suppose position in the x direction on the x-axis, which is represented by I cap plus j cap. The position in the y-axis represented by j cap. We differentiate it with dr by dt to dx by dt I cap with dy by dt j cap. This is v. Suppose the resultant of the velocity of both the axes. This is vx, that is the velocity in x-axis. This is velocity in y-axis. The velocity also has two components, that is x and y. If we again differentiate this, this will come as a equal to ax I cap plus ay j cap. This is what 2D motion is basically. All of these have two dimensions to it. These have two components to it. That's why it's called 2D motion. Now we can write the equations of motion from this 2D motion also. So there's a rule of thumb, that is, when you're looking at one axis, forget about the other. Okay, it's like a relationship. When you're in a relationship with someone, just forget about the others. Okay, similarly, if you are looking at x, forget about y. And when you're looking at y, forget about x. Okay, so this is a very important rule. Now, how does this apply? Suppose you're looking at the y-axis, so x-axis, so forget about y. So the equations will be vx equal to ux plus axt, sx equal to uxt plus minus half ax t square, bx square equal to ux square plus minus 2ax sx. Here also, when you're looking at y, forget about x, which I clearly can't. This is y t sy equal to uyt plus minus half ayt square dy square equal to y square plus minus 2ay sy. This is equation of motion in 2D. We have studied 1, 2, 3 in the previous chapter. Why? Because these are graphs of 1D motion. And why is that? Because in first one, the ball goes up and the ball comes down. There's no displacement in the x direction. Everything is happening in the y-axis. The ball is going up. This is also in the y-axis. The ball is coming down. This is also in the y-axis. There's only one axis involved. Similarly, when dropping the ball is changing position and having velocity in just one axis, that is y-axis. The ball does not have a velocity in this direction, in x direction. Right? So this is also one thing. And third, also the same. Ball goes up like this, fall like this. Displacement in, sorry, the velocity was in this direction and just in the opposite direction. That's it. Only one axis, that is y-axis involved. Okay. But in 4, 5, and 6, these are 2D graphs. The main graph we'll be talking about is 5. This is what the entire chapter is based on, basically. Now, this is a particle launched with Vx with angle theta. What does this mean and how is this 2D? When there's a velocity v with an angle theta, this is basically the resultant. And for a resultant, we can break it down into components. This v, we can write it down as v cos theta and v sin theta. If you have studied vector, you know this. This is velocity in x direction and this is velocity in y direction. Okay, so this has the two velocity components x and y, so this is 2D. This is the sixth one is just a similar case, but from a tower. Suppose height h. Showing a velocity, this has a Vx, Vy, according to the theta with the horizontal, so it just becomes like this. Now in the fourth one, with throwing a ball completely horizontally. Okay, now you may ask, what is 2D in this? You are just throwing a ball in the x-axis, so the velocity is just in the x-axis, right? You're correct. That is initially when the guy is throwing the ball. But after a point, because the motion is like this, the path is like this, how do we find the velocity of a curved path? This is a curved path, right? That is by drawing a tangent. Suppose this is a tangent, or I'll draw it properly. This is a tangent, so the velocity in this direction. Okay, this is the velocity. Now this velocity has some theta with the or alpha angle with the horizontal. Okay, this would also have a vertical angle. So we can break down this also into components. This is Vx and Vy. Okay, so initially it has only initially it has only velocity in the x direction, but because g is acting downwards, v is uy plus gt. Suppose this is, you'll understand this later. Suppose the equation is like this when you're looking at the y-axis. So the Vy initially is 0 because it is just throwing, the man is just throwing the ball with u horizontally. That is, horizontal velocity is u. So the vertical velocity, initial vertical velocity is 0. So Vy equal to gt. Okay. So basically the Vy will be acquired because there's acceleration in the downward direction, that is gravitation. So initially there was only one in the x-axis, but finally due to the gravitation, Vy will be acquired. Now we'll be starting actual ground to ground projectile motion when there's an angle with the horizontal. Okay. Suppose this particle is at origin, launched with velocity v with angle theta. So the path is going to be like this. Okay, the ball will fall here, velocity v. Now, y-axis and x-axis, we have some precursors to her. That is, in the y direction, g is acting. That is in this direction, in the downward direction. And in the horizontal x direction, the velocity and the acceleration is 0. No acceleration is acting in this direction. Unless some wind resistance and stuff comes in, that is exceptional case, which is completely out of a curriculum. This is the basic framework. Okay, gravitation is acting downwards. and there is no horizontal acceleration. So if we break down this v into its components, that is v sine theta to vy, v cos theta equal to vx, then the horizontal velocity is this. Okay, this will be the max height, and the ball is starting from here. Suppose this is 1, this point is 2, and the topmost point is 2, and this point where the ball is landing, it's 3. We just name the points. So the distance between 1 and 3, that is where the ball is starting, the displacement between the initial point and the final point, this is called the range of the projectile. Represented by r. The time of flight is nothing. The time of flight is basically the time from going from 1 to 3. Going from here to here, completely traveling the path to 3. And what is h max? This is the maximum height reached by the projectile. This is the basic framework of a projectile motion. On the previous precursors that we had talked about, that is the velocity in the acceleration in the y direction was g, and the horizontal acceleration is 0. So there are some inferences we can take from this. That is, suppose we'll talk about the x-axis. Okay. So when we're looking about the x-axis, the ax equal to 0. And when acceleration is 0, that means uniform velocity. Uniform motion, sorry. Uniform motion, which means velocity is constant. Okay. So the Vx would be constant. So through the whole motion, at any point, suppose I'll take here, we start from here, this is Vx. At any point, the horizontal velocity will be same. You can just take any point because the acceleration in the horizontal direction, that is in the x-axis, is 0. So the velocity Vx would be constant. Even the direction is constant. Okay. Now, I'll just write it in different pen. Horizontal velocity constant throughout the projectile motion. Now, if we look at the y-axis, so we can see that this is the projectile, this is Vy, this is Vx, this is V, this is the path. And we're looking just at the y component. We can just assume it like the motion of a ball when we threw it up with a velocity u vertically upwards, and it fell down with the same velocity but in the negative direction. Because we're neglecting this, we can just picturize it, picturize the motion like this. Okay, so what did happen here? A ball was thrown with velocity u, it became 0 at the top, at the maximum height, and it fell down with the velocity, with the same velocity, just in the opposite direction. Exactly same thing is happening here. The Vy, because the g is acting downwards, decreases up to this point, that is the maximum height, and becomes 0. Okay, and then it increases till this is Vx, till it becomes minus Vy. It goes up with Vy, just like in here, it goes up with u and comes down with minus Vy, just like here it comes down with minus u. Okay, So this is another inference. When y-axis is considered, the motion is same as when we throw the ball upwards. Ball vertically upward. Okay. And another one is that we've already discussed about this, that the velocity, the vertical velocity at this point is dx, is dy. So it decreases, 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 and at this point, the maximum height, the vertical velocity becomes 0. And horizontal velocity is obviously here, right? Horizontal velocity is same everywhere throughout the motion. So the horizontal velocity is here, the vertical velocity is 0. So at the top, this is another inference. The velocity is minimum as the Vy vertical velocity becomes 0 at top. Okay. Just because this is a curved line, you can draw a tangent here like this. So the direction of velocity is this. Vx is obviously same. The Vy changes, which is smaller than this Vy, the initial Vy, suppose Vy dash, because the g is acting downwards, right? Opposite direction to velocity, velocity and acceleration are opposite direction, so velocity decreases. It decreases, the velocity is here, again Vx. This is suppose Vy1, this is Vy2, and at this point it completely decreases. Now draw a tangent to this line. Similarly, it increases in the negative direction, so the velocity is in this direction. Vx is same, Vy is present, suppose Vy1, again the Vx is same, the velocity is like this, the Vy which is greater than this Vy, and at the end Vx is there, this is minus Vy, the initial one. Like the initial one was this one, so the minus of the initial one. That's it. This is projectile motion. So now we'll start by learning the formulas of maximum height, range, and time of flight. Start with time of flight. Now, time of flight is going from point A to point 2, or this is 3, suppose. This point is 2. The entire time required to go from 1 to 3 is time of flight. Now, this is concerned with the vertical component of velocity. I'll tell you that. Because to find the time in the equation v equal to u plus at, you need an a. If you look at the x-axis, vx equal to ux plus at, axt, so ax is 0 and vx equal to ux. That is, suppose vx only starts with vx. Basically, this does not make any sense. There is no time component here because the ax is 0. This thing just gets cancelled to 0. You can't find out the time of flight with respect to x-axis. But if you see the y-axis, then vy equal to uy plus minus ayt. Now, suppose this direction is positive. Okay, the upward direction is positive. The downward direction is negative. So g will be negative. Okay. If we look at this, then vy the initial velocity, initial vertical velocity, and this is the final vertical velocity, right? So the final vertical velocity is minus Vy equal to, what was Uy? This was positive Vy, and then plus minus G, as we have taken the G as negative, T. So it's minus 2Vy if we just take it here, equal to minus Gt. The minus signs get cancelled out, and the time of light, this is the time of light. Okay, the time of light comes as 2Vy by G, so 2V sine theta by V. This is the formula of time of light. Okay, so now you know, because the acceleration is 0 in the x-axis, so this thing, the whole AT thing becomes 0 for the x-axis, and in the y-axis, if you just put in the equation of motion, the first equation of motion, you just get the time of light. Okay, remember this formula. Now we'll talk about the height, h max. This is also a function of the vertical, because here h max, first of all, it is in y-axis, so only the vertical component will be considered. This is the basic thing. Okay, you can understand this by, suppose this is the displacement, that is h max, from the point, this point to this point, 1 to 2. So the displacement s equal to h max. Initial velocity, v initial equal to Vy plus Vy, and the V final equal to 0, because in 2 the vertical velocity becomes 0, only horizontal is present, that is at the top. The vertical velocity equal to 0, only horizontal velocity is present, right? And Ay is obviously minus G, because we took the downward direction as negative. So if you put it in the third equation of motion, that is the final velocity square equal to initial velocity plus minus 2as, we can write this as 0 square, because the final velocity is 0. The initial velocity is v square, now plus 2 minus g into h max. This will be minus v square equal to minus 2g h max. Minus signs get cut out. H max equal to Vy, sorry, this is Vy. Vy square by 2g, or v sine theta whole square by 2g. Okay, this is formula for height max. Basically, just take the journey up to here. This is the initial point, this is the final point. The displacement is h max. The initial velocity is Vy, obviously, and the final velocity, final vertical velocity equal to 0. The horizontal velocity is obviously present, but since we're looking at the y-axis, we have to forget about the x-axis. So just put it here and solve, you'll get this. Now the range. Range is basically the distance from the initial point, distance from the final point, that is this, the initial point, on the y-axis. Sorry, x-axis. This is in the x-axis, right? So it will be concerned with this. But also, what is distance? Range is basically distance, right? Distance between this point and this point. So what is distance? Distance is velocity into time, or velocity equal to distance by time, time equal to distance equal to velocity. We'll just take it here, velocity into time, right? Now time we have got to go from this point to this point, the initial point to final point. What is that time called? That is called time of flight. That is t, capital T. So we've got this t. What is this Vx? Now the displacement, sorry, what is this velocity? That is Vx because the displacement is in the x-axis. The velocity to displace it in the x-axis should be the horizontal velocity, that is Vx. So R equal to Vx into T. This is the basic formula. Okay. R equal to Vx into T. If we rearrange them, that is R equal to Vx into 2Vy by G. You can write this as R equal to 2Vx Vy by G. You can write this. This is the first one. And also, if you break it down into components, that is R equal to 2 V cos theta dot V sin theta, because Vx is V cos theta and Vy is V sin theta. If we just segregate this 2 sin theta into cos theta and take the V common, or just we'll do it in the next step, that is V square into 2 sin theta cos theta by G. Now this sin theta cos theta, 2 sin theta cos theta means trigonometrically sin 2 theta. You have to know trigonometry for this, which is taught in the basic maths lecture. So you can also write this as R equal to U square sin 2 theta by G. Okay, where this is the initial velocity. So this is it. I'll just write in a fresh form here with 3 formulas. That is time of flight is 2Vy by G equal to 2V sin theta by G. H max is Uy square by 2G equal to U sin theta whole square by 2G. And range is, first of all, it's Ux into T. Second, you can write it as 2Vx Vy by G by breaking, just putting the value of T here from here equal to V square or U square, suppose this is the initial velocity, sin 2 theta by G. These are the formulas of projectile. Now, for the formulas we have discussed already, we have to find the maximum and minimum values of the formulas. We'll start with time of flight. This is basically basic trig. Okay, I'll show you how. This is Vy by G U sin theta by G. Now, if sin theta maximum, then the numerator is maximum, then the time of flight is maximum, right? So, sin theta, the value max is 1. And when does this happen? When theta equal to 90 degrees, because sin 90 equal to 1, which is the maximum value of sin. So, when theta equal to 90 degree with horizontal, then maximum POF occurs. Okay, so basically it's this motion only. This is Vy. It's 90 degree, it's making 90 degree with the horizontal. So it's basically the motion we talked about in 1D. Okay. In this case, POF maximum. We talk about the maximum height. H max. H max is nothing but Dy square by 2g or q cos square, or no, sorry, sine square theta by 2g. Now here also sine is in the numerator, so the maximum value of sine is 1. If this value is 1, then the height max is the maximum. Okay, the maximum value of height comes. So this is also the same case, theta equal to 90. This is max. So here also, when theta equal to 90, H max has the maximum value. Just like the previous time of lightning. This also follows relationship like this. 90 degree with the horizontal, 0. Now, range. Range is Pdx dy by g, what? G square sine 2 theta by g. Again, this is sine theta on the in the numerator, but it is sine 2 theta. So for the maximum value of sine theta will be, whether it be sine theta or 2 theta, will be 1. Because more than 1 is numerically impossible. So theta, the total theta has to be 90, that is sine 90 equal to 1. So for theta, it was 90. So when 2 theta is given, this also has to be 90 for this to be 90 for the value to be 1. Theta equal to 45 degree, or just logically think this value has to be 90. So just it is 2 theta, so 2 theta equal to 90, theta equal to 45. Okay, so when angle with horizontal is 45 degree, the range is maximum. Also, for complementary angles, okay, I'll come to this later. Just know this right now, that the range is maximum for 45 degree with the horizontal. Now, if we compare two projectiles, okay, suppose this one has velocity v1 here, and this one has velocity v2. Okay, and it is told each max is same in both. This is same for both. Now, what does this mean? First of all, we can write this as H max 1 and H max 2. Now, this is Vy, this is Vy1, okay, Vy1 here, and Vy2 here. So, the Vy1 whole square by 2g equal to Vy2 whole square by 2g. Now, g is equal in both, so they get cancelled. Write it in here. If you see, this is Vy1 square equal to Vy2 square. Take a root on both sides. This comes as Vy1 equal to Vy2. That means when H max same, the vertical velocities are also same. Now, or if you take when time of flight same for the same projectiles, suppose uh, this is 2by1 by g equal to, sorry, TOF1 equal to TOF2, that is 2by2 by g. G gets cancelled out, 2 gets cancelled out. Here also Vy1 equal to Vy2. Here also we can write when TOF same, Vy same. The vertical velocity is same. This is the same statement we wrote for maximum height. Now, if this is the inference combined of the other two inferences, that if H max of two projectiles same, then the time of flight is also same, and vice versa. If the time of flight is same, then the H max of the two projectiles is also same. Why? Because they both deal with Vy, that is vertical velocity. And a vertical velocity of 1, and if any of these are equal, then the vertical velocities of the two projectiles come equal. So these go hand in hand. Now we come to the range. There's this one point we have to mention for range. That is, for complementary angles, range is same if projected with same velocity. Okay, I'll explain this. That is, suppose it's launched with u with 30-degree, and another projectile, this is projectile 1, this is projectile 2, another projectile is launched with 60-degree. You know the rule of complementarity, right? The addition of these two angles should be equal to 90. If the first one is 30, second one is 60, they are equal to 90, so they are complementary to each other. Also, suppose 45 plus 45, this is also 90. So 60 plus 30, this is also 90. Basically, you know complementarity, it's taught in basic maths. So, if complementary are same. Okay. In these two also, suppose this is 37-degree and this is 53-degree, just the initial velocities with which they are launched has to be same. This is the basic criteria. This is also 37 plus 53 equal to 90. They are also complementary. This is the equation of a projectile. You don't have to literally remember this or anything. Just watch the derivation. If you want to remember this, you can. But in books, it is given. Also in Kaplan, it is given. So I have to show you that this is the x-axis. This is the y-axis. This is the x-axis. This is b. Let's say the u. Path is like this, and this takes this distance as, suppose, random distance x. Okay, and random distance y. Don't take it as range, h max or something like that. Okay, just random coordinates x and y. So suppose displacement in y direction equal to u sine theta dot t plus or minus, or means half g t square. And just write minus here altogether. Okay, and the x direction, the displacement is Vx into t. We have already talked about this. Like in range also, we have found that it is velocity Vx into time of flight. So similarly, in the x direction for any random x coordinate, it is Vx into t, and the horizontal velocity into time. So if we just rearrange it, time comes as x by Vx, which is x by v cos theta. And this is obviously uy, which I've written directly as u sin theta. So I'll just put this in this equation, substitute t, substitute t. So it will be y equal to u sin theta dot x by u cos theta minus half g x square by u square by cos theta square. This is squared completely because it's t squared, right? So this is the sin theta by cos theta is x tan, now minus half g x square by u square cos square theta. Now, if we manipulate this by this multiplier sin theta and divide it by sin theta, so it's basically 1, so it doesn't matter if we cut this out. So we have to rearrange it like x tan theta minus half g x square by u square cos theta. I'll just take one cos theta from cos square theta here, cos theta, and I'll take the sin theta here, sin theta. Now obviously there is sin theta in the numerator, there is a sin theta there, and I'll take another cos here. Now why did I do this? First of all, sin theta plus sin theta by cos theta, this is tan theta, and also the formula for range was 2bx v or ux uy equal to 2 u sin theta cos theta by g equal to 2 u square sin theta cos theta by g. And this 2 sin theta cos theta was mathematically sin 2 theta by g. This was the formula, right, of range. If you can see, this is nothing but 2 u square sin theta cos theta by g. Just it's the reverse. It is u square sin theta. This is 2 u square sin theta cos theta by g. This is g by 2 u square sin theta cos theta. So this is nothing but x equal to x tan theta minus x square by r tan theta. The tan theta comes from here. Okay. So just take x tan theta common. You can write this as 1 by x by r. This is basically the equation of projectiles. That's it. So how to find the angle at any point in a projectile? Suppose this is Vy or Uy, Ux, and we have to find the angle at this point. At this point, this will be some random velocity. The horizontal component will always be same, that is Ux, and the vertical component will be something else, okay, not this. So the vertical component can be explained by Vy equal to Uy minus dt. At any point, you can express the vertical velocity as this, the initial velocity minus dt. This is the first equation of motion. Okay, so suppose this is an angle alpha between them. So just to find the angle between them to tan alpha equal to Vy by Vx. So tan alpha equal to Uy minus dt by Vx, or this is one, or you can just write the value u sine theta minus dt by u cos theta. Okay, so solve this whole thing and we'll find the tan theta and the angle from here. Okay. Now we had seen how to find the angle when it is ground to ground, that is like this. But in problems like this, where a man is standing on top of the tower and he just shoots a ball with a horizontal velocity, suppose uf, and the path of the ball is like this, obviously. So initially, at time equal to 0 seconds, what will be the velocities? So ux is ux because it throws at, the man throws the ball with ux. If we consider the y-axis, the velocity at any point should be, because here also the precursor are same, ax equal to 0, ay equal to minus g. So uy plus minus gt or minus gt, right? So the initial, there's only horizontal present. So the vertical velocity, initial vertical velocity will be 0, and minus, it is also talking about time equal to 0 seconds. So t is also 0. So initially, mathematically, it's also proven that the vertical velocity, initial vertical velocity at time equal to 0 seconds is 0. Now suppose we're talking about a point like this. Let's zoom in here. So the ux will be same, and because of the g, a vertical velocity will be acquired. And if you draw the tangent to the line, velocity is in this direction with an angle, suppose alpha, with the horizontal. So velocity at any point can be given by, it's the same, it's literally the same, minus gt. So ui equal to 0, uy equal to 0, so vy equal to minus gt. So we can write this as ux gt minus gt, because of the direction we can omit this because we're already considering the direction as downwards. So gt with the velocity this, angle theta and an angle alpha. So just write tan alpha equal to gt by ux. There's the same thing, just one component is omitted here. That's it. For the same projectile, we can also find the range also. So what is the range? Range was basically ux into time of flight. Right? What is time of flight? The time taken to go from point here to here. Right? So we can just put the equation of motion and we can see that, suppose this is the displacement, right? From this point to this point, the displacement is basically h, the height of the tower. So s equal to h, and we're taking the downer side as positive, so that the displacement becomes positive, that it is displacing it in this direction. So it will be plus h equal to uyt plus half gt square. And in this case, we're taking g as positive because the downer side is positive. So h equal to qt becomes 0 because uy initial vertical velocity is 0. This is half gt square, time of flight equal to h by g qt. So the range here is ux into root 2 h by g. This is the range.